Okay, uh, I'm great to be your teacher for this course. And my name is Xiaoping Yang. You know, it's very common. It's very common name in China. Right? Yang, many people. This name Yang and Xiaoping, right? Okay. So yeah, I'm from another college, College of Chemistry and Materials Engineering. Okay, so we call it like general chemistry. So basically, the goal of this course is to provide some basic knowledge of chemistry that you may use in your study and research in the future. Okay, so we have 16 chapters for this course. Okay, and so today we will introduce the first and second chapters. So yeah, schedule is Friday morning, this time each week. Okay, and yeah, grading. So basically, homework. After for each chapter, you will assign some questions. Okay, homework. And you need give me the homework next Friday. So the homework will be due by the next Friday. So basically, you need to prepare 2 notebooks. Okay, because one in my hand, right, will give me, but you need to use another one to do your new homework. So basically, you need to prepare 2 notebooks. Okay, and of course, after 1 week, I will return one to you, and then you give me your homework, that one. Okay, and the homework will be like the final grading is 30%. 30%. Okay, so you should finish your homework carefully. Okay, and the attendance 10%. Okay, and so we will have a final test. So it will be 30%, 30%, 6%. Okay. So first chapter is about introduction to chemistry. So in this chapter, we also introduce like the matter. What is matter? Okay. So in this chapter, we will introduce what is chemistry, and also the concept about the matter. So what is chemistry? So basically, you can find different answers online. Okay, here I just use 2. Okay, one is about chemistry. It's about molecules. They are shape, structure, and reactivity. Okay, and you know molecules are everywhere in your mind. And this means chemistry affects everything. So chemistry is also, this means it's very common and also important. So another way to call chemistry is the study of matter and the transformations it can undergo. So this means we study the matter, and also we study their transformations. So, and then here we will introduce the development history of the chemistry. Okay, we'll simply introduce the history of the chemistry. Yeah, because that is true. The echo, right? Okay. So basically, the beginnings of chemistry is exists in our life, right? The alcohol, the device, and also the weapons, all about chemistry. Okay. So first we can, for the development of chemistry, we can set like these three edges. The first is called Greek's edge. Greek's edge is like during this time, okay, during this time. So basically, at that time, of course, the chemistry is very simple. Right? So for example, the Greeks believed that there were just four elements, like earth, air, fire, water. Okay. Also, you can find this kind of symbols in some place. Okay. So this is the first edge, and the second we call alchem edge. Alchem. So do you know alchem? Alchem edge. Alchem. Okay. So and also now also we call chemistry. So alchem is like basically, yeah. At first, some guys, you know, they want to turn cheap materials into gold by magnetic materials. Okay, you know, because gold is always expensive in the history. Okay, so some people just want to turn some cheap materials into gold like copper, right? Iron. This is very cheap metals. They want to change these metals to gold. So this guy is called alchem. Okay. So this is also the beginning of the chemistry, because when they want to change some materials to gold, then you do some experiments, right? So this experiment is about chemistry, okay? And for example, copper, it's called like the philosopher's stone. Put some philosopher's stone, they can change the gold. Now we know it's possible. It's possible or not now?
It is.
It's possible. Yeah, it's not possible, of course. Yeah, basically, in ordinary chemical reactions, we can't transmute elements into different elements. Okay, but at that time, people want to do something like this. Of course, they failed, right? Okay. So this is, but they also contribute a lot to chemistry. For example, they developed some experimental technologies, right? And also they found some new gas wells, and also they get some information about elements, and also they synthesize several elements. Okay, so this is about the alchem. Now we know this edge we could call this chemistry edge. So the chemistry chemistry is about the study of matter and its changes. So you can see why we call chemistry. So this chemi is tri. So we know what this means. So chem is tri. Chem is tri, right? So what's mean tri? Tri means you need to do something, right? You need to do experiments. So basically, chemistry in our chemistry, like college, so students should always do some experiments. And also, I think you also learn chemistry in your high school, right? Yeah, we also do some experiments. Yeah. Okay, so this is for chemistry. So of course, when we do experiments, you need using some equipments. Of course, this is a picture to show some very simple instruments for measuring volumes. So yeah, you should know this, right? this. So this Buret. So do you use this before?
Yes. Yes.
Oh, good. Yes. Okay. And this packet.
Yeah.
Yes. Okay. Yeah. This is very common. Okay. This just very very simple and common instruments is in chemistry. And of course, yeah. Questions.
Are we going to have experiments in finding examples?
But
Are we going to have experiments of finding examples?
oh no, no. You know, final example. You know, final example, right?
Exactly.
No, final example just give you questions, so you just finished in 2 hours. Final test. No experiment of this course. Okay. Yeah. No experiment. Okay. And of course, if you in our college, students should do a lot of experiments, but you know, this is just general chemistry. Okay, so you just you just need to know some just very basic knowledge about chemistry. Yeah. Okay. Yeah. Okay. So basically, the areas about chemistry. So you know, this is periodic table of the elements, right? So basically, chemistry include like organic chemistry, inorganic chemistry, biochemistry, and physical chemistry. Okay. So organic chemistry is the study of carbon-containing compounds. Carbon-containing. Okay. Like our body and some lives, they all like organic chemistry. Okay. And inorganic chemistry studies everything except carbon compounds. So others you can call inorganic chemistry. Okay. Like stone, right? Metals, okay, and some metal compounds. So this is about inorganic chemistry. And biochemistry is living things, okay, biochemistry. And also physical chemistry. Physical chemistry is about the measuring physical properties of substance, like the melting point, something like this. Okay. So this is the first part. So this we introduce the development history of chemistry. Okay. We also introduce what is chemistry. Okay. So the chemistry is study of a matter. So what is matter? Yes, anything that occupies space and has mass is called matter. So here we can see there are 2 concepts. One is mass and that's the weight. So what is the difference between the mass and weight? So mass is like the quantity of matter, right? Quantity of matter. But the weight is the force that gravity exists on an object. So the weight equal like C is like coefficient and mass. Yeah. And for example, on Earth, the C you can see is like 1. It's like this means on Earth the mass is the weight. The mass is the weight. Okay, but like on Moon, okay. So what's the weight? The weight, the coefficient is 0.1. So this means 1 kilometer like will weigh 1 kilogram on Earth, but 0.1 kilogram on Moon. Okay. So the weight on Earth for the same object, the weight on Earth and on Moon are different. Okay, you can weigh with the weight of an object, we can get different numbers, differently. This is because the force, the gravity, is different. Why? Because the Earth is larger, right? It's much larger than the Moon, right? So the gravity on Earth is higher than that on Moon. So this one, for one object, its weight on Earth is larger than that on Moon. Okay? So this is about weight. Okay. So what the matter is made of? So now we know it's made of atoms, right? All matter is made up of atoms. So, and because one atom can't be changed to another atom. So this is why the top can't be changed to gold because they have different atoms, and the different atoms can't be changed to each other. Okay. And now we can see the atoms using like scanning tunneling microscope. So, for example, this picture is a graphite. It's the surface of a graphite. Like we can get this picture, okay, using this microscope. So for each point, it means one atom. So the atom like this, one atom, okay? So we know the structure of graphite is hexagon structure. It's like this, right? But why? You can see here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? 6 atoms in this way. In this carbon ring, okay? Here, one atom, Y. At the center, we can also find one atom, Y. Because this is just one layer, right? This two layer. So this two layer, they will be like this. Okay, so the red one is one layer, okay? The white one is another layer. So for this one, there are one atom from the white layer, right? So we can see at the center of this ring, there are one atom. Okay, so this guy comes from another layer. So under the microscope, we can see picture like this. So this means now we can see the atom using the microscope. Okay, and this is the size we also introduced later. So we say all matters are made of by atoms. So for example, the gold. This is the gold, right? So the structure like this. So each one is the gold atom. They just stay like this and to form the gold structure. So so gold, we can say we can call it is element. Okay. So element is a substance that can be separated into simple substance by chemical means. So for example, we can find many stable elements on Earth. And for some elements, they are not stable. They are not stable. So they will stay with other elements, okay, to form a new matter, Okay. So we can say like it's metals and no metals. Okay. This is about element. So elements is just made by only one kind of atom. One kind of atom. Okay, it's called element. For example, we can use these symbols to describe the elements, the different elements, right? For example, this is metal, right? Nickel, and this is all metals. But this is no metals. So all this we can find on Earth. So they are stable. They are stable on Earth. We can find them. Okay. So this is some common elements, and they are symbols. Okay. So one atom can be from one element, but some atoms can combine together to form compounds. So a compound is a substance composed of atoms of two or more elements. Like, for example, this is lithium fluoride. So it includes two atoms, two kinds of atoms. One is lithium, right? Li. Another is fluoride, F. So this kind of matter is called compound. It's called compound. Okay. So compound is made by more than one atoms. And of course, they can be separated into they are pure elements by chemical means. So we say the copper can be changed to gold because copper is the smallest atom. Okay, but for compound, they can be separated to their elements. Okay. So dry ice because it's carbon dioxide, right? So it also includes two atoms, carbon and oxygen. But they are stable. They are very stable. Okay. So they are called compounds. Okay. So here we can say the matter. What substance is matter? Okay. For example, so basic matter, one is mixtures. One is pure substance. So mixtures, it means more than one kind of objects. They are mixed together. This is mixtures. So if only one object, so it's called pure substance. So and of course the mixture can be separated to pure substance. Okay, for mixtures, there are two kinds of mixtures. One is homogeneous mixtures. Heterogeneous mixtures. So anyone can give me some examples for what is homogeneous mixtures and what is heterogeneous mixtures? and this. and you know, there are, you have, oh, no, I think you have Chinese name.
Right.
Oh, you're not in this.
Jiang
Okay, anyways, the first, you know, it's always difficult for me to call your name.
It's always interesting to try.
Okay. The first mark name, Tata. You right? Okay, first one. This means the first 1, 2, 3, 4, 5, 6, 7, 8, 9 is not in here. Yeah. So other 11 here. Okay. So can you give us some examples, like what kind of mixture are homogeneous mixture and heterogeneous? I'm not sure. Okay, I'll give you an example. L. L, yes, L. L is a metal, right? Yeah. So it's a homogeneous mixtures or heterogeneous mixtures. What? Is it heterogeneous? No. Homogeneous means just, for example, air is in one state, right? So this is homogeneous. Like air, look at something air, liquid, right? Gas, they all gas, right? So this all the materials are gas. So this is Yes, it's homogeneous. Homogeneous is just all of them are gas or liquid or solid. Okay, this is called homogeneous mixtures. If this mixture includes two more states, like gas and liquid, so this is called heterogeneous mixtures. So anyone can give me example for this one? Blood. What? Blood. Blood. What blood?
Human blood.
Human blood. Okay, yeah, you can see, yeah. Like also, for example, drink, right? They drink liquid. Also, they also some gas inside, right? So this is kind of heterogeneous mixtures. So this is about mixtures. Okay. So the second one is about pure substance. Pure substance. So pure substance includes two kinds of pure substance. One is compounds, another is elements. So we know they are different, right?
Yeah.
Yeah. So elements is just only like oxygen, right? Oxygen gas. It only includes oxygen atom.
Yeah.
Okay. And the carbon dioxide, yes, is compounds. And the compounds can be separated to elements. Okay? So this is about matter. So there are 4 kinds of matters. Okay, yeah, here is about 3 states of matter. So first is solid, liquid, gas. Okay? And in this picture, we can it shows the 3 states of water, right? So this is ice, it's solid state, right? And you can gas, okay, water gas, and also the liquid water.
Ice juice.
Yeah. Okay. So for changes, it includes 2 kinds of changes. One is called physical change. Another is called chemical change. Yeah, physical change doesn't change the like properties of the substance. Like the ice melting, so it changed from the water just changed from the solid state to liquid state, right? So it doesn't change the substance. So this change is called physical change. So another kind of change is called chemical change. So this, yeah.
It's changing in color of something. Is it a physical change?
For color change, so maybe it's physical, maybe it's chemical. It depends. It depends. Okay. Chemical changes means, of course, they change the composition of the substance. For example, the hydrogen can burn in air, right, to form water. So in this change, the hydrogen react with oxygen to form a new compound, water, right? Yeah. So at first, both of them are elements, right? But after this change, they become a compound. So they are composition or their structures change, right? Change. So this kind of change is called chemical change. Okay. So for properties, there are also two kinds of properties. One is called extensive properties. Another one is intensive properties. So extensive properties depends on how much matter is being considered. So for example, the mass, volume. This means the more matter, the large number of these properties, right? If you have more substance, of course, their mass will be high, right? And also their volume will be large, right? So this kind of properties are called extensive properties. This means this property can add each other. Okay, we can add them. Another property is called intensive property. So for this property, it doesn't depend upon how much matter is. For example, the density and the temperature, okay, and the color, okay. So no matter how much they matter, they will be the same, right? They will be the same. So this kind of properties are called intensive properties. Okay. So basically, we can use different units to describe their properties. Like for the length, we can use meter, okay, and for the mass, kilogram, and time in second, okay. Oh, this is carriers in chemistry. You can do many things in chemistry. Like you can do some research, right? And you can there are also production and the development and also teaching, like me. Okay. And we also know chemistry is very important in our life, especially like in health and in medicine, and also like now we know energy, right? Energy and environment. All these are about chemistry. So so this chapter is just simply introduce what is chemistry, okay, and also the development of the chemistry, and also introduce some basic concepts in chemistry, like the properties, right, and something. Okay, so that's all for chapter 1. Chapter 1. So we will continue to start the chapter 2. How to find it? Here. Okay, so chapter 2. So this chapter is about the atoms and the atomic theory. So in last chapter we introduced the matter. What is matter? What is chemistry? You know, chemistry is about matter, right? And what is matter? And also what the matter is made of. Is made of. So we say the matter is made up of atoms. So this chapter we will introduce atoms and also the atomic theory. So basically we will introduce the law of conservation of mass, and we also introduce the law of definite properties, and also introduce the models of the atom and the symbol of atom. So, and we will also introduce how did the atomic theory of matter develop and how was it improved. So, in different time, people using different way to group the atomic nature of the matter, atomic nature. Now we can see the individual atoms and the molecules. Right? These two pictures we introduced these two pictures in last chapter. So this is another picture to show the atoms. We can see using a microscope. For example, on the graphite, we can put the chemical. This organic compound. This is organic compound on the graphite. So this compound includes 22 carbon. So this 21. So 22 total 22, and the structure is a linear structure. So under the microscope, we can see this is the molecule. This is a picture of the molecule. Okay. So this is 1 carbon, 1, 2, 3, 4, and you can find total 22 atoms, 22 carbon atoms. Okay. So this is also another example to show that we can see the atoms using the microscope. Okay. So now we introduce the first law about the atom. So this is a law of conservation of mass. So it's raised by Lavoisier. So he is also called the father of modern chemistry. And he said in every chemical operation, an equal amount of matter exists before and after the operation. So what does this mean? This means after one reaction, the amount of the matter will not change. Okay?